In this video, we're going to talk about undefined values that occur in rational expressions. One of the things that we need to consider when we're simplifying rational expressions is that there are going to be some values of our variable that we need to exclude from the solution because they're not in the domain of the expression. They're values that cause us to have to, values of the variable that cause us to have to divide by 0 in the expression. And so we're going to exclude these. You see here the big idea. Any value of x or whatever variable we have that causes division by 0 must be excluded from the domain. So when we factor the expression, we're going to figure out the values that cause division by 0. These values that we exclude are what are known as restrictions on the variable. Okay? So let's go ahead and put this into practice. This is actually a relatively simple process. For part A, we're going to find the restrictions for the following. So any values that would cause division by 0. Well, the easiest way to do this, if we go ahead and just factor this denominator, and that denominator factors as x plus 1 times x plus 6. Now, in order for x plus 1 times x plus 6 to be equal to 0, that means one of these factors has to be equal to 0 in order for it to result in a value of 0. And so we need to find the values of x that make x plus 1 equal to 0, and the value of x that makes x plus 6 equal to 0. And those are relatively simple to find. We can go through the mechanics of solving these equations, or we can simply, ask ourselves, hey, what value of x makes x plus 1 equal to 0? It's negative 1. And what value of x makes x plus 6 equal to 0? That's negative 6. And so those are our restrictions. And so for this problem, we can't have x be equal to those values. And so our restrictions would look like this. X cannot be equal to negative 1 or negative 6. And so those are our restrictions in part A here. In part B, we'll do the same thing. We'll look at what values of x make this denominator equal to 0. We factor. That factors as x minus 4 times x plus 2. The values that make each of these 0, that's x equals 4 makes that 0, and x equals negative 2 makes that 0. And so our restrictions are going to be that x cannot be equal to 4 or negative 2. And so those are our restrictions. That's how we find restrictions. Alright, let's go over to the last set of problems here. We're going to simplify these, and we're going to state the restrictions. So now I'm going to go through the whole simplification process. I'm going to factor both the numerator and the denominator. And there are our factorizations for those. And now I'm going to find my restrictions from this original. X can't be equal to negative 4. X can't be equal to positive 3, because those are the values that are going to make the denominator equal to 0. So now I'm going to simplify this. X minus 3's cancel out. And this reduces to, and this is how we're going to write this, this reduces to x plus 6 over x plus 4, and we're going to put a semicolon, and our restrictions. X can't be equal to negative 4, and it can't be equal to positive 3. And there's our simplified form with the restrictions stated. Alright, let's look at part B here. Wow, this one looks tough. So let's see, I can factor GCF out of the numerator. And I can factor GCF out of the denominator. And then I've got more factoring to do in both. It's going to be x minus 5 times x plus 3. That's going to be x minus 5 times x plus 1. And so I'm actually going to start with my restrictions here. You look at your denominator, What values of x make this factor equal to 0, x squared? Well, in order for x squared to be equal to 0, that would mean x equals 0. And so x can't be equal to 0. That's one of our restrictions. Positive 5 for the next factor, 3x minus 5, and negative 1. And so those are our restrictions. And now we'll simplify this. We can cancel an x minus 5 out of both, and we can cancel an x out of both, numerator and denominator. And so we're left with 2 times x plus 3 in the numerator, and x times x plus 1 in the denominator. And there's our simplified form with the restrictions. Alright, that concludes our video on finding restrictions in rational expressions. See you next time.